In the last video, we learned all about the normal distribution, or sometimes refer to it as the bell curve. And we worked with it and were able to answer questions about a population that was normally distributed. And it was, we were looking at the heights of male Dutch, right? Male Dutch. So we answered all sorts of questions like, what percent of Dutch men are at a height between this many centimeters and that many centimeters, and we were able to come up with the answer using the 68, 95, 99, 7 rule. And so remember, the idea is that in every normal distribution, we know that if we go to a z-score of -1 to a z-score of 1, that between those values, you're going to find 68% of your population, or 68% of your data. And if you go to a z-score of -2 and then go up to 2, in that region, you're going to find 95% of your population, or 95% of your data. And if you go back and look at that previous example, every height for a Dutch male that I asked about always fell on a nice integer value z-score. So it was -2 or -1 or 1 or 2. And so that allowed us to use that 68, 95, 99, 7 rule to answer those types of questions. Okay. However, what if we did not get a z-score that was something really nice like -1 or 1? So what we're going to focus on now is, how are we going to figure out the percentage of our population or of our sample that is between two values or less than a value if those z-scores that we get are not nice numbers? What if they're decimals? All right, so that's what we're going to look at here. So in this first example, it's asking me, what if I'm going between -1.2 and 1.2 on the standard normal curve? And remember, this language of the standard normal curve or the standard normal distribution is just saying it's the normal curve where along the horizontal axis we're talking about the z-scores. So they're wanting to know, okay, what percent of the curve does this represent? So the one answer, I guess, to how we answer this question is with calculus. Okay, but of course you don't have to have taken calculus to take this class. So what we're going to do is we're going to let technology do the calculus for us. So on WAMAP, in our Rossmann-Chance applets, so again, go to important class links and documents, go down to the bottom to the Rossmann-Chance applet collection. We want to click on Normal Probability Calculator. All right. So in this Normal Probability Calculator, it allows us to type in, and yeah, that should be fine. We'll go right there. It allows us to type in z-scores. So you can leave all this alone, right? Leave it exactly as is. And all I need you to do is type in, first of all, check these two boxes, and then type in the two z-scores we're interested in having as our boundary. So I just type in -1.2 for my z here, and 1.2 for my z here. Now the answer is going to be this value right here, the probability between. Okay, so these two values are giving you, this one's giving you the percent or the probability of being from there and below. So that's about 11.5%. That's the same thing that this probability is giving you. So from there and below is 88.5%. but it's the probability between that we want to have here. So 0.7699. So we can just take that down right here. Oops. .7699, which is of course 76.99%. Okay, so for this next one, it says find the percent of the standard normal distribution less than z equals 0.5. And so this time our picture well, here's 0. Well, I guess here's 0. And so 0.5, you know, again, I'm trying to make it somewhat accurate so that I can envision -1 and 1 containing about 68%. So, you know, I'm going to put it right about there for 0.5. And so if we want to be less than that, then that means we're wondering what percent of the curve falls below that. So in a case like this, what you're going to do is only have one of these boxes checked. So you can uncheck one of them. And then you're going to put in the z-score that you're interested in, 0.5. And you notice that it shaded everything below 0.5. So this answer that it's giving you is the answer that we want to report. So 0.6915 is the proportion of the curve below a z-score of 0.5, which means 69.15%. And by the way, as you're doing homework, if it asks you to give a percentage and puts a percent symbol after the answer key, then you can of course type it in like this. But if it's just asking for a proportion or a probability and they're not using a percent sign, then you can type it in its decimal form. All right, and then this last example, find the percent of the standard normal distribution greater than z equals -1.4. So I kind of went to the next line on accident. So again, here's the curve. And we are interested in, well, here's 0. And, you know, I look up here, it's good to just think back to the 6895 rule. So, you know, I'd want to put -1.4 in a spot about equivalent to this place right here on my sketch up at the top. So, you know, I might put it right here. All right, but we want to go greater than that. So on my calculator, what I can do is I can go ahead and type in -1.4, but notice that it's still telling me the percent below it, and we want to know the percent above. So all you have to do is click on this button and it'll switch. Right? So we can see that the answer we're looking for is 0.9192. Which is 91.92%. So that's how you're going to tell me what percent or what proportion of the normal curve falls either between z values, below a particular z value, above a particular z value, if those z-scores that you calculate don't end up being something really nice like 1 or -2 or something like that. One other thing we want to be able to do using technology is to find the z-score on the standard normal curve for particular percents of the distribution. And so in this case it says find the z-score, tell me the z-score, if the percent to the left is 45%. So let's sketch a picture of what we're wanting here. So if we're wanting 45% to be to the left, then what we're looking for is, of course, a z-score that is a little bit to the left of 0. So here's 0. So we're looking for this z-score right here, where if we look at the proportion to the left, we would get 45% or 0.45. So that's the picture of what we want. We want to be able to report that z. So again, if I pull this thing up, now what I can do is I can type in the probability and then it will spit out to me the z-score. So I just type in 0.45, but of course I don't want 0.45 above. We can see from my picture that I want 0.45 below, so I hit this button and then again that switches the side that is shaded. Notice that when I do that, however, that it automatically switched it to 0.55 because what it thought is that I just wanted to go to the left of that particular z value. So if you hit this button, you may need to adjust, right? So to tell it, okay, I do want 0.45 as my proportion to the left. So just watch that if you hit this switching button. All right, so 0.45 gives me a z-score of negative 0.126. So the z-score equals negative 0.126, just as expected, because 45% is pretty close to 50%, and we know a z-score of 0 would give me 50%. All right, in this example, find the z-score on the standard normal curve so that the percent of the distribution to the right is 5%. Okay, so we are looking for the z-score that gives us a picture that looks kind of like this. So using our technology, so this time I'm going to think ahead about the fact that I really want the right side shaded. So I'm going to hit this button before I ever change my probability. And then I'm going to put in 0.05 for my probability. And so I can see that that corresponds with a z-score of 1.645. In this last example, we want to find the z-scores that form the boundary for the middle 40% of the normal distribution. All right, so since that's what I want, what we want to do is, remembering that between a z-score of -1 and 1, we're going to get 68% of the distribution. So that means, I want to narrow it up a little bit. So there'll be some values in here. I want to know what they are so that this here is 0.4. So I want to know what is this z-score here, and since we want to find two z-scores, we'll call that one z low and we'll call this one z high. Now we just finished figuring out what the z-score is if we know the proportion to the left or if we know the proportion to the right. So what I suggest we do here is make this into a problem that looks like one of these first two, meaning if I know 0.4 is in the middle, do I know anything about what's on the edges? Well, of course, right? So if 40% is in the middle, then that means I have to have 0.3, right, on both edges in order for it all to add up to 100%, right? So 100% minus 40% is 60%. Half of 60% goes here and half goes here. So in my technology, what I'll do is I will tell it, okay? So notice it's shading in the left for me. So I'm going to tell it that I want 0 0.3 to the left. That's what I want. And so I can see that my z-score is negative 0.524. So that would be for my low. And for my high, same thing. So I'm going to turn that inequality around. And again, type in 0.3. And of course, not surprisingly, because we know the distribution is perfectly symmetric, I get positive 0.542. 524, excuse me. All right, so what are the two things we learned how to do? We learned how to use technology to figure out the proportion of the curve, or the percent of the curve, that is within a certain region based on knowing the z-scores. And then we also said if we know the proportion, we can figure out what z-score is at its boundary using technology as well. And in the next video, we'll figure out how this is going to apply to real-world populations and real-world data.